Okay, so today I'm going to talk about how we can solve this particular inequality. Okay, so seeing a modulus inside the inequality may be a bit intimidating at first, right? But if you notice, this is actually not much different from writing this. Right? Because x squared is the same as modulus of x squared, right? So I can actually replace x squared with modulus of x squared. Okay, so today I'm going to talk about a technique to deal with this kind of inequality, right? So this is what I will do. Okay, so instead of solving this directly, I'm going to solve this first, okay? So I'm going to solve the inequality without the modulus. Okay, so you notice x equals to 1 is actually a root, right, of this. So you can sub 1 inside, 1 cubed minus 3 times 1 squared minus 1 plus 3. That's going to give us 0, right? So x equals to 1 is a root. Okay, so in other words, I know that x minus 1 is a factor. Okay, so knowing that x minus 1 is a factor, I can do a long division to get the other factor, right? Which is going to be a quadratic factor. Okay, so I'm going to divide this by x minus 1, right? Since I know that x equals to 1 is a root. Okay, so this would be x squared, right? So this is x cubed minus x squared. Okay, so negative 3x squared minus plus x squared is negative 2x squared, right? Minus x. So this is negative 2x. So this gives us negative 2x squared plus 2x. Okay, and we subtract that. Negative x minus 2x, negative 3x plus 3. Okay, so multiply this by negative 3, we will get negative 3x plus 3, which is good, right? Because we're going to get a remainder 0, right? If you don't, then something is wrong, right? So we should, because x minus 1 is a factor. Okay, so I know that the other quadratic factor is x squared minus 2x minus 3. Okay, so this inequality becomes this, right? So I can actually rewrite it as this. X squared minus 2x minus 3 less than 0. Okay, so let's factorize this further, right? So x squared minus 2x minus 3 is actually x plus 1 times x minus 3. Okay, so I'm going to solve this inequality now. Okay, so let's draw a number line to help us. Okay, so let's look for all the zeros, right? Meaning the roots. Okay, so I know that one of them is negative 1, and the other one is 1, and followed by 3. Okay, so let's look at any number that is greater than 3, right? For example, right, I can choose x equals to 4, right? So if I pick 4, right, I can substitute inside this, and I'll get 4 minus 1 times 4 plus 1 times 4 minus 3. Okay, so that is going to give me a positive value. So I put a plus here. Right now, I can choose any number between 1 and 3. Right, so let's say 2. Right, so I can substitute 2 inside here, the same thing. Okay, and I'm going to get a negative number. And then I'll choose a number between negative 1 and 1, right? Maybe 0, right? So 0 minus 1 times 0 plus 1 times 0 minus 3. Okay, it's going to give me a positive number. Okay, and lastly, we do the same. Pick a number that is less than negative 1 here. Right, substitute inside. You should get a negative number. Okay, so take note that this inequality asks for less than 0, right? So if it's less than 0, we should be looking at the minus. Okay, so that's where our answer will lie in. Okay, so I know that, okay, x has to be less than 3, greater than 1, or x is less than negative 1. Okay, so that's actually the solution to this particular inequality, right? So this blue color inequality. Okay, so how do I make use of this result to solve this inequality? Okay, so notice that actually from the expression, I just have to replace x with modulus x. okay, which is what I'm going to do here. Okay, so if I replace x with modulus x, right, this is modulus x less than 3, greater than 1, right? This is modulus x less than -1, right? But notice that modulus x cannot be less than -1, right? So we have to reject this, right? Modulus x is always greater equals to 0. Okay, so now we're just left with this. To solve this is quite simple, right? So let me just draw a graph. Okay, so it's easier for you to see. All right, so let's say this is, the y and x axis, right? Okay, so this is the y axis, this is the x axis, and modulus of x should look something like this, right? Okay, it's not drawing very well. Okay, so something like that. Okay. So that is our y equals to modulus x. Okay, so what does this mean, right? Between 3 and 1. So I'm going to draw two horizontal lines, okay? So one of them is y equals to 3. Okay, so this is y equals to 3. And this is y equals to 1, right? Okay, so I want modulus x, y equals to modulus x, to be in between these two horizontal lines, right? So I'm going to look out for these values. Okay, so this value is actually 1, right? So when y equals to 1, x is 1, right? So, and this value is 3. This value should be -1, and this one should be -3. Okay, so notice that when my x is in between 1 and 3, my modulus x graph will be in between y equals to 3 and y equals to 1, right? This region, right? I'm going to circle the region. So this is the region that we are looking at. Okay, so our solution, right? Our solution to this is x less than -1, greater than -3, and x less than 3, greater than 1, right? So that is our final solution. Okay, so this is how we solve this kind of inequality. All right, if you find this video helpful, please like and subscribe, and I'll see you in the next one.